Continuing on in the mode of solving for trigonometric identities, I suggested that you always convert to sine and cosine. So let's see if this principle works. Here's another interesting question where you're trying to solve for the right-hand side and prove that it is equal to 1. So what should we do? The first bracket would give us 1 over sine x. Convert the cot into cosine x over sine x, and that will be multiplied by the same thing on the right hand side but with a plus sign. So that will be also 1 over sine x plus cos x over sine x. And what do we have to do? We have to render these two, and what we have is a common denominator situation, and I use something that is very simple to understand. We're going to cross multiply, and that will give you sine x minus sine x times cos x, close bracket. Down below, what do you have? You have the product of the sines, and that will give you sine squared x down below. We still have to do the square bracket. The square bracket will give you the exact same solution except for the plus sign. So again, cross multiply, we would get times sine x plus sine x times cos x. This entire bracket will once again be divided by sine times sine, which is sine squared x. Now this looks a bit miserable, and you're wondering, well, where's this going to go? But from your grade 10, you should remember factoring for the difference of squares. You'll notice that the terms are the same, and there's a minus and a plus. So we can multiply the top two terms, and we would get a difference of squares solution. So if we FOIL, if we take these two terms and FOIL to the right, what will we get? We will get sine squared x minus sine squared x times cos squared x. And that is still divided by the two terms below, which is sine squared x times sine squared x. Now at this point you're still wondering, how is this ever going to resolve to become 1? You should know that we could take this out, and in the top you'll notice there's a factored form. We can take out a sine squared x, and what would that leave us with? This would leave us with sine squared x times 1 minus cos squared x in the numerator, still divided by our old friend sine squared x times sine squared x. But what do you notice now? There's a cancellation. And are we done? Not yet. One final step. Who is 1 minus cos squared x from Pythagoras' theorem? As you recall, that would be sine squared x, and it's divided by the original sine squared x. And what do you notice? We have our solution. That is equal to 1. And there you have it.